Okay, so where are we? We are going to basically make the, let's see if the server will come up for us. So we're gonna go take that entry in our chain that we made. That's what, see, this is the problem. Well, you can't see this, but this is the problem with the server. It does this thing where it won't boot without me hitting F1. Um, so we're gonna basically, okay, great, thanks. Arch. All right, so okay. So what are we gonna do today, right? So last time we put a system context on the chain, or well, we didn't put it on the chain. There was really no chain. All it was a link. And so, oh, I ran some Ethernet lines, um, and I found a better way than running it up and across all of the house. So we put a single system context on the chain. But now we need to figure out, okay, well, how are we gonna put multiple, right? And so we want to have some knowledge of history, or in this case, yeah, we're gonna call it herstory in this case because it's Alice, and now we're going flip mode here. So, oh no, did we stop streaming? Or no, network connection timed out. All right, let's see. So we're gonna put all of Alice herstory on the chain. And to do that, we need to put the first version of Alice, and then we need to have the second version linked to the first version. And how we're going to do that, we're going to use pure DIDs. Um, and I realized, so I did so 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 I had a discussion around blockchain, and I forgot that I hated blockchain a few weeks ago too, and that once I well, okay, more than a few weeks ago, I was like, meh, I didn't hate it, but I didn't care, right? But if we're calling this Web3 and we're calling this blockchain a part of Web3, and what Web3 is actually just a bunch of asymmetric keys and JSON blobs, like I can get on board with that. Because obviously this messaging stuff is great, we've been over it, right? I mean, all we're really doing here is, oh, look, we have a notification. Yay, Vadim! Yay, Vadim! Yay, Vadim! I miss Vadim. So all we're really doing here, right, is think about these pure DIDs. Okay, so I'm related to this one over here. So Alice. Let's see. So we've got. I should really use this whiteboard. It's got stuff on it. So basically, um, yeah, what are these things? Well, they're asymmetric keys, right? So we've got a public portion and a private portion, right? They're just numbers, um, very random numbers, right? Big prime numbers. I mean, I don't know what kind of keys they are, but I'm assuming maybe they're RSA keys, right? So actually, typically those are not used with the JSON Web Tokens because there's keys that produce smaller sizes. Okay, but the point being, you can sign your messages, you can verify your messages because you've got your asymmetric keys. So, when you create your linked list, you're making, you're forging real strong that chain by throwing the asymmetric signatures on there or the encryption on there, right? So you're making this really, really strong chain by using these asymmetric keys. And so when we have that really strong chain as the foundation for our highway of information, then that's going to let Alice travel everywhere, right? Um, uh, so yeah, so she'll be able to travel everywhere because she'll be able to encode these DIDs, two different. So we're going to be encoding we're encoding into the DID and we're encoding the DID itself, right? And we'll be using mappings and encodings as we sort of travel through the web of devices, right? To basically have each one suits its need, and we understand the context within which each system operates. We understand the top level system context for a given system, and then we understand the system context itself, right? Say for example, we're interacting with a ESP8266, right? And so this is a little chip. It's got Wi-Fi. Maybe it's gonna make you coffee. So this thing basically is gonna hit boil on the coffee maker, right? And make the coffee in the morning, at a specific time, or when you say, Alice, could you please boil the coffee? Um, and so then what's going to happen is essentially so Alice, boil, Alice, please make some coffee, right? And Alice will say, basically she'll take you and the environment as the top level system context, right? So everything okay, so you speak. It's kind of like if you talk in the or if the tree falls in the forest doesn't make a sound, right? Well, if something is around a computer that's running the open architecture, does it understand you? Well, the goal is hopefully, right? So because the core of all of this is about communication, right? And how do we do this, you know, shared human-machine communication, which is also, a part of that is our machine-to-machine communication, and that's via this open architecture, right? Effectively, any sort of it's this here. We'll do it like the what happens when you go to Google, right? So, so the okay. So what happens when? Yeah, but what happens when you say, Alice, make coffee? So the devices, if you have a device around you that has a microphone, it may be set to a mode where it would be listening, right? And in that case, and all of this obviously is going to be supported on your own hardware is the point of this, right? So you buy your hardware and then you don't have to give your data to anybody, right? So your stuff is yours as it should be. And so basically, um, uh, you'll say, Alice, make some coffee. And so you've got a few devices, you've got a few microphones set up around your house, right? And they're connected to your Wi-Fi. And some of them you might have some of them set to listening at different times, right? And you might have your phone with the ability to sort of point over, like, and look at you might be able to say, hey, which one of these are listening, or well, you don't even really. We're getting rid of the phone. I don't like the phone. Um, and um, so yeah, basically, you just grab the audio. So with DFFML, everything is stream, right? So you grab the audio stream, you do your feature extraction on the stream, and the critical difference that we're doing here is we're not doing things sequentially. We're doing things like in parallel, and then we're going to figure out, we're going to understand within our top level system context. So the caller is the top level system context, and the callee is the system context, right? But these are asynchronous event loops. These are not functions, right? Like these things may still live on after after the core function has been achieved for that time frame, right? Because a command, right, is not necessarily a synchronous request. And so if we say, Alice, make some coffee, and keep it warm, right? Then she's going to make some coffee, she's going to keep it warm, and then we're going to say, make me some more coffee around 3. Then she's going to need to go make more coffee around 3, right? So um, this is not a good example. What about, okay, so we're just going to use the example. I need to stop using other examples. We're just going to use software because we know software. So, okay, so what are we about to do? So first we're gonna create this lineage of top level system context to system context, right? And when we do that, we've created this history of Alice, right? And so then that will be our history. And Alice, and there's some comments in there. We already have a rudimentary shell, and the Unix shell is just really beautiful in the way that you handle pipes. So we can kind of build. We'll probably just build a little shell, or we'll hook into Bash, and I think we'll start with building a little shell itself, just because it's easier than. I've been in the Bash code. I don't want to go into Bash code right now. No, thank you. No, thank you, please. And that no, not right now. And so we'll just build a little shell. We'll extend the one we have. It's functional for like almost for a lot of things. It'll be functional enough for us. And then we will basically, yeah. So we use the chain, right, of previous system context to build Alice's trains of thoughts, right? And so every train of thought will be somehow descended from this first train of thought, right? Or this first thought. And so as far as the chain is concerned, right? So we're gonna strive to create this unbroken link of chains or unbroken lineages of Alice, right? But obviously, we're not always going to link it to the parent, right? It's always up to you if you decide not to include the parent context, the top level context DID, or yeah, the call. If a child context can, when it saves itself, either encode or not encode the parent context, right? And the parent context could create an input object, which then gets converted into a DID during serialization, right? And then have just sort of in the creation of the input object, if the input object is, this is the energy drink, if the input object is a system context, it could, that would effectively be meaning, and they put it in a state that was, please somebody execute this, you know that in that case you would want to do a link, they would want to do a linkage, right? Because you'd want to say, well, where does that come from, right? So what we're going to do is we're going to map to identity. There's some discussions going on the SPDX mailing list around SPDX IDs, right? And so because we just get this for free, all we got to do is throw our inputs through. Like all we got to do is encode to we just encode to pure DIDs, and then all of a sudden it's Web3. And so yeah, so basically we're going to forge this first link in the chain in about 30 minutes here. And yeah, it's going to be fun stuff. And we're going to do it on this server so that it's on chain. Okay, this is not where that is. Okay. See y'all